So I'm sure looking at just these pictures at the very beginning of the notes, you're probably thinking that what we're going to be doing in this lesson is maybe a little bit crazy. Let me see if I can kind of walk you through it, just so you get an idea before we even start doing any of the math, anything at all. Let me give you an idea of exactly what we're going to be looking at. So we're looking at systems of equations in 3 variables. So I'm sure you saw some of the examples on the next page. A system of equations just means you've got a set of equations, more than one of them. 3 variables because if you see on the next page, all of our equations have x's and y's and now z's. So we've added in a 3rd variable of z. So these systems, when you're looking at an equation that has 3 variables in it, what you get is this 3-dimensional graph that's in the shape of a plane. So you can see, obviously the picture itself, the paper itself is not in 3 dimensions, but you can see that we've got these sketches of 3-dimensional graphs. And so when you're looking at a system of equations in 3 variables, these 3 planes can intersect each other in multiple different ways. Here's one solution. We've got these 3 planes kind of all going in different directions, but all 3 of the planes meet at this one point. X, Y, Z, this is called an ordered triple rather than an ordered pair because now we have a Z. So X, Y, Z is an ordered triple. Or we've got this option of infinitely many solutions. That happens when all of the planes intersect in a line. In this situation, every coordinate on this line would be a solution, and so there are an infinite number of solutions. One thing that's not pictured would be if all 3 of the planes are exactly the same, and then every single coordinate in that plane would be a solution. And that would happen if every single equation was equivalent. Several options here for no solutions. No solution just means that there are no points in common with all 3 of the planes. So that could happen in multiple different ways. They might not all intersect each other at all. There could be 3 parallel planes. That seems like the obvious answer. Or there could be 2 parallel planes with one of them running down the middle. Whatever the scenario is, there's not a single point that's common to all 3 of them. All right, so that's what we're looking at. And so if you get some sort of visual of what we're looking for, it's either going to be a point or infinitely many solutions or no solutions. And that's the same 3 possible answers that we could have had when we were doing just 2 variable equations as well. All right, so now that you've kind of got the overview, we are going to flip over and take a look at our first example. All right, so our goal, remember, is to get the ordered triple that makes all 3 of those equations true. There's either going to be exactly 1, or there could be no solution, or there could be infinitely many solutions. All right, so solving these systems, it's really actually very similar to solving systems that just have 2 equations. So we've learned the substitution method, and we've learned the elimination method. We're kind of going to do a combination, really, of the 2 methods. All right, so let's actually sneak in, up at the top here, let's sneak in some steps. So step 1 is to eliminate one of the variables using 2 pairs of equations. Okay, so eliminate one variable using 2 pairs of equations. So get that written down. That's going to be our first step. So let me explain exactly what that means. Picture the elimination method. We did it with equations that just had an x and a y. What we did is we got the 2 equations stacked right on top of each other, and we got one of the variables to cancel. And the way that we did that was by getting opposite terms, like a positive 4x and a negative 4x or something like that. So now here, we need to eliminate one variable, but we're going to do it twice using 2 different pairs of equations. So first of all, just to keep us straight, we've got 3 separate equations to work with, so we're going to go ahead and label them. So we've got these 3 equations here. The first one, so we'll just label them A, B, and C. That way, instead of me saying, negative 3x plus 5y plus 2z equals negative 27, I can just say equation B. And then we all know what we're talking about. So I would get in the habit of doing this when you guys are working on your homework as well. So we're going to try to eliminate one of the variables. So if we look at the x's, 2x, negative 3x, negative 5x, none of them look like they're ready to eliminate. We don't see any opposites here. And then look at the y's. We've got a positive 4y, positive 5y, positive 3y. None of them are ready to eliminate right now. And with the x's and the y's, not only are none of them ready to eliminate, but like the 2x wouldn't even easily eliminate with the negative 5x. I'd have to multiply both of the equations. That just doesn't sound like fun. I think I've told you guys before that mathematicians are lazy. We look for the easiest way to do things. So the easiest way to do things comes down to this z. Notice how that z is by itself. It's ready to be multiplied by anything we want, and we can get the z to eliminate. So with this first problem, we want the z to eliminate first. You don't have to. You could get the x's to eliminate first or get the y's to eliminate first, but I'm just giving you my advice that the z is going to be the easiest one to eliminate because in this third equation, it's all by itself. So look at these two equations, for instance, b and c. See how we have a positive 2z right here, and this one we have a negative 1z. What we can do is get them to cancel out. If this were a negative 2z, then it would cancel with the positive 2z. The only way to do that is to multiply equation c by 2. So we are going to take equation c, multiply it by 2, and then combine it with equation b. That's going to be our first move here. All right, so starting with equation c multiplied by 2, so that means everything gets doubled. So the negative 5x gets multiplied by 2, and I get a negative 10x. The positive 3y gets multiplied by 2. The negative z gets multiplied by 2, and the negative 17 gets multiplied by 2. All right, so I took that entire equation c, I multiplied the whole thing by 2, and now I'm going to combine it with equation b. So just write down equation b exactly the way it is. Okay, so what we're going to do is do the elimination method, round 1, combine everything up. So add these two together, so negative 10x and negative 3x gives me a negative 13x, combine like terms. These two, the 6y and the 5y, I get 11y. These ones cancel, and they better, because I just worked really hard to make sure that they do cancel. And then equals, now these two, when I combine them up, I get a negative 61. All right, so now I have an equation with two variables. Now I'm kind of back in familiar territory. I'm comfortable with this. I'm going to label this equation D because I'm going to come back and use it in my next step. Okay, so we're not quite done with step 1 because it said to use 2 pairs of equations to eliminate one variable. So I need to use another pair of equations that will also eliminate the z. Okay, so in step 1, it's very important that both of your combinations eliminate the same variable. So I already used b and c. And I told you guys I really like using this equation c because the z is by itself. So I'm going to do some sort of combination of a and c. So equation a, again, see this 5z, this negative 5z right here. So the only thing that a negative 5z will cancel with is a positive 5z. So we need to make this a positive 5z. And we do that by multiplying the whole equation by a negative 5. So I'm going to take equation c, multiplied by a negative 5, and combine it with equation a this time. That way I'll have a negative 5z and a positive 5z, and they'll cancel. So I'm going to take all of equation c, multiply it by a negative 5. So when I multiply this first term by negative 5, I get a positive 25x. Here I get a negative 15y, a positive 5z, equals, and the negative 17, you can always feel free to break out the calculator if you need to. Multiplying a negative 17 times a negative 5 gives me a positive 85. Okay, always be careful that you're very careful with all your multiplication because one little mistake will throw these whole problems off. Okay, and then combine it with equation A. So write this down exactly the way it is. So now you can see once we get to that step that we've done something right because these z's are going to cancel. So I finished the elimination method, combined my like terms, 25x and 2x gives me 27x. Negative 15y and a positive 4y gives me a negative 11y. These cancel, which they better, equals, and then over here I get a 103. Okay, so now again, we're going to come back and use this equation. So we're going to label this equation E. Okay, so what I've done is I've now gotten myself to a point where I only have 2 equations that each have 2 variables. So like I said, totally back in familiar territory. So now step 2 is going to be to solve the system of 2 variables. So now whatever technique I want to use to get D and E. So now I need to solve for X and Y, and then when I'm all done with that, I'll go back and solve for Z. So these two, if we're taking a look at equation D and E, these are beautiful for the elimination method. Notice I have a positive 11y right here. I have a negative 11y right here. I don't even need to work for it. They're ready to cancel out right now. So for step 2, I'm going to combine equation D with equation E. So here's equation D. Again, no changes necessary whatsoever. And then right underneath it, equation E. No changes necessary to this one either. Okay, so I'm going to combine them up, working on the elimination method here. So combine like terms here. I end up with a positive 14x. My y's cancel, and I am finally down to just one variable. And then this equals 42. Okay, so I'm still working on that second step. We're solving this system of two variables. So to get the x by itself, I divide both sides by 14. 14s will cancel right here. So I get x by itself, and then if you simplify 42 divided by 14 gives me 3. So that is one of my values. I'm 1 for 3, but unfortunately, if it makes you feel any better, the hard part is pretty much over. So now I take 3 and I plug it back into either one of these equations, either one I want, so that I can solve for y. So let's just take the first one. So I want to now solve for y. So negative 13, I'm using this equation right here. Instead of x, I'm going to plug in my x value of 3. And then plus 11y equals negative 61. So negative 13 times 3 gives me a negative 39. So I'm working on getting the y by itself right now. So I'm going to add 39 to both sides. Okay, these will cancel. I get 11y equals, and then when I simplify this up, I get a negative 22. So last step to get y by itself is to divide both sides by 11. So I end up with a y value of negative 2. So now I'm 2 for 3. See how much faster that was? And then the last step is to solve for z. Okay, so now I have 2 of my answers. Now I plug them into one of these, one of the equations that have 3 variables. I would go with the last one, just because the z is by itself. So negative 5 times x, instead of x, I plug in a 3, because that's my answer right here. And then plus 3 times y, but again, instead of y, I'm going to plug in the negative 2. Minus z equals a negative 17. So all I need to do is simplify this up, solve for z, and I am done. So negative 5 times 3 is negative 15. 3 times negative 2 is a negative 6. Minus z equals negative 17. Negative 15 minus 6 gives me a negative 21. Minus z equals negative 17. So I'm just working on getting this z by itself. So I'm going to add 21 to both sides. Okay, these will cancel. I get a negative z equals a positive 4. So dividing both sides by a negative 1 gives me z equals negative 4. So just like I've had you write the x's and y's as an ordered pair, you write the x, y, and z as an ordered triple. So my ordered triple would be 3 for x, negative 2 for y, negative 4 for z, and that is your final answer. That's the one point out in that three-dimensional space where the 3 planes intersect each other. All right, so just in the interest of time, we're going to skip this one, go down to example number 2. Okay, so solve each system of equations. So, once again, we are going to label these so we can keep everything organized. We're following the same 3 steps, so A, B, and C. So if we look at the z again, is what looks easiest. Because for step 1, we want to eliminate one variable by using 2 pairs of equations. Always look for the one that's easiest to combine up with other equations. Since this z is by itself, it's easily manipulated, easily multiplied by other things. So look at the one right below it. Oops, that's a 3z, a positive 3z. So if this were a negative 3z, they would cancel. So to get it to be a negative 3z, I need to multiply that top equation by 3. So I'm going to take equation A, the first one, multiply it by 3, and then add to that equation B. So then I'll have a negative 3z and a positive 3z, and they'll cancel out. So first, I'm going to write down equation A times 3. So multiply everything here by 3, get a negative 12x, negative 6y, negative 3z equals 45. So that is equation A tripled if I multiply everything by 3. Then right underneath it, I'm going to line up equation B. Okay, so now I work on the elimination method. So when I combine the x's up, they cancel. When I combine the y's up, they cancel. When I combine the z's up, they cancel. So I have nothing left on my left-hand side. Everything is canceled out, no variables remain. Equals, and then 45, 45, add those up, I get 90. So 0 equals 90, false. That is not a true statement. So I end up with a false statement. We saw things that were very, very similar to this when we were looking at just the two variables, two equations. If you get a false statement, what that means is that there's no solution. So let me show you. If we're looking at this first plane versus this first plane, all of the variables match up, which means I know slope is a very strange thing when I'm in 3 dimensions, but that means that these planes run parallel to each other, so they don't ever intersect. So if these two planes don't ever intersect, then it doesn't matter what the third plane is doing, because there's no way that all 3 of them could ever intersect each other. So I just end up with no solution. So the second that I get a false statement, go no further, it's just no solution. All right, so let's look at another one of these. Example 2, part B. We are going to once again run through the same steps. We'll start by labeling A, B, and C, so we know what equations we're talking about. So now this time, if we look at, let's see, oh, this is really nice. The negative 2z and the positive 2z, they're ready to go right now. So I can just combine up equation A and equation C, and I don't need to simplify anything or multiply anything. So start with equation A. And then right underneath it, line up equation C. Okay, so line everything up here, combine up the x values, I get a negative 11x. Combine up the y values, I get a negative 12y. The z's cancel, which again, they should. And then when I combine up the constants, I end up with a negative 6. Okay, so I've got an equation in 2 variables, so I'm going to label this D, because I might need to come back and use it. So now let's figure out some other combinations. So I haven't used equation B yet, so I definitely need to use equation B. But remember, step 1, I have to eliminate the same variable both times. So since I eliminated the z this time, my second combination also has to eliminate the z. So if I look at equation B, I know I'm definitely using that equation. The one right below it, I have a positive 2 times z. If I had a positive 4, then these would cancel. So I can multiply this bottom equation by 2. So I have a 4z that would cancel with this negative 4z. So if I take c and I double it, I can combine it with equation B. All right, so twice equation C, we'll start there. So multiply everything by 2. So I get a negative 28x, I get a negative 34y, I get a positive 4z, which is exactly why I multiplied this by 2, equals a negative 38. Okay, so that's the first equation, doubled. I'm sorry, the third equation, doubled. Then I want to combine it with the middle equation. So a negative 5x, negative 2y, negative 4z equals 20. No changes for this one. Okay, so they're all lined up, ready to go. I multiplied my third equation by 2 so that I would get opposite z values, which would cancel. Combine these up, I get a negative 33 times x. Combine these up, I get a negative 36 times y. The z's cancel, just like they should, and then I get a negative 18 on the right-hand side. All right, so this is equation E. So I've made it through the first step. I have done 2 different combinations that both eliminate the same variable. And so now my second step is to use these 2 equations and cancel out another variable. So if we're looking at these, we're going to try to do some sort of elimination. So look at the x's, for example. Here I have a negative 11x. Here I have a negative 33x. If this were a positive 33, it would cancel with this negative 33. So I'm going to multiply this by a negative 3. If I multiply by a negative 3, I end up with a positive 33x. That will cancel with this negative 33x. So I'm going to use equation E exactly the way it is, and then take equation D and multiply it by negative 3. So again, E exactly the way it is. And then I'm going to multiply everything in equation D right here by a negative 3. So multiply this by a negative 3, and I get a positive 33x. Multiply this by a negative 3, and I get a positive 36y. Multiply this by a negative 3, and I get positive 18. So hopefully you see where this is going. So we go to cancel, and everything cancels. So on the left I have 0, on the right I have 0. Compare this to example A on the previous page. 0 equals 0, that is a true statement. If you come up with the true statement, what that means is that you have infinitely many solutions. Infinitely many solutions. So now the three planes weren't exactly the same, but what happens is when we found the intersection between the planes, it ended on the exact same line. So this is just like the picture that we had on the previous page, where all three of the planes intersect in a line, and there are an infinite number of points on a line. So if we come up with a true statement at any point in the problem, we can stop right there and say that we have infinitely many solutions. All right, so just really quickly with example 3, we're not going to go all the way through, but I just want to walk you through how you'd set up a story problem so that we hopefully have a little bit easier time while we're working through the problems in class. So we've got $50,000 in 3 different accounts. One of them has 8% interest, one of them has 10% interest, one of them has 12% interest. So when I have you guys doing story problems, as I'm walking around, one of the things I instruct you to do is to figure out what the unknown quantities are. What quantities do we need to know? So this is how much did she invest in each account? We need to know how much did she invest in the 8% account, how much in the 10%, how much in the 12%. So let's set up our variables. A is the amount that she invested in the 8% account. Let's say B is the amount that she invested in the 10% account. And we'll say C for the amount that she invested in the 12% account. So let's go through sentence by sentence. One thing to point out, however many variables there are, that's how many equations you need. So 3 variables needs 3 equations, just like we've had in all the problems so far. So first sentence, she invested $50,000 in 3 different accounts. So what that means is that A combined with B combined with C gives a total of $50,000. That's our first equation. That one's pretty easy just based on the sentence. She invested 3 times as much money in an account that paid 8% than an account that paid 10%. So the account that paid 8%, that's A, was 3 times as much as what she had in the 10%. So it was 3 times what she had in the 10%, which is B. So this is kind of a little baby equation here, but that's going to be important. The third account earned 12% interest. If she earned a total of $51.60 in interest, how much did she invest? So this one's going to be a little tricky. This equation is going to represent the amount of interest. So 8% interest for account A, we would write 0.08 for 8% times A, and then plus for the 10%, she made 10% interest off account B, and then plus she made 12% interest off of account C. So again, I'm not going to actually finish the problem. I just wanted to walk you through how to set up the equations because I think that's what we have the most difficult time with story problems. All right, so that's it.